Hello, welcome to everyone in this video. This is our lecture number 73. Already 72 lectures covered to solve the problem asked in this book, that is Electrodynamics by DJ Griffiths. Actually, this is the part 30 of this book solution, and rest of the lecture consists the solution of this book, that is the Basudev Ghosh book, Electricity and Magnetism. If you want to watch the previous lecture, you can go through the description box, link are given there. Okay. In this video, I want to discuss question number 7.01, problem number 7.01 to 7.06 of, of chapter 7 of this book, that is Electrodynamics by DJ Griffith, right? So let's start with question number 7.1, which says that is two concentric metal spherical cell. These two are the two concentric metal spherical cell of radii A and B, respectively separated by a conducting material. Within this material, within this cell, between these two cell, there is a conducting material is sigma. If there are maintain a potential difference, if we maintain there is a potential difference between these two cell is V, what current flow from one to another, right? So you know this the electric field within these two region. You can, using Gauss theorem, you can easily find out the electric field within that region, that is 1 by 4 pi epsilon naught q by r square r cap. Then the potential difference is nothing but the minus b to a e dot dr, simply integration. You can get this potential difference, and you know the current is nothing but jds, and j is sigma e, and e dot ds is q by epsilon naught, and q is nothing but, you can see here, this is the v is this, so q is 4 pi epsilon naught b, and this epsilon is cancel out, so we will be get this one. So finally the current expression will be 4 pi sigma v by 1 by a by 1 by b, right? I think clear about this expression. If there is any doubt, you must comment in the comment box. Go to the next one. What is the resistance between the cell? You need to find the resistance between these two cells. You know resistance is nothing but voltage by current. Here the voltage we already obtained, or you can put this value of I is whichever you can put. If v by I, so this will be in up and this will be down. So this is up down. You will be finally get this answer. Very easy. Next one. Notice that if V is very much greater than to A, the radius B is invariant. So if V is very much greater than 2, so 1 by B tends to 0. So this will be event. How you account so that? So this corresponding current will be like that and resistance will be like that. Just put this value in the 1 by B equals to 0 in this expression. That is I equals to 4 pi A sigma V, and the corresponding resistance 1 by B equals to 0. So the corresponding resistance will be 1. 4 by sigma A. This is the value of resistance. Clear? Now, for the submerged sphere, here there is a concept says that express this observation to determine the current flowing between two metal sphere, each of radius A immersed of deep sea. There is a metal sphere of radius A deep in the sea level, and the potential difference within this is V. This arrangement used to measure the conductivity of seawater. Actually, this is the practical uses of the how we can measure the conductivity of seawater. Is this is the arrangement? Okay. So the corresponding resistance will be like that, because there is two sphere. For single sphere, resistance is this. So for two sphere, this is the resistance, and current is voltage by resistance. Voltage by resistance will be get, this is the current flowing through this system. Next one. A capacitor C has been charged up to potential V0. This capacitor charged by this potential V0 at t equals to 0 connected to this resistor and bring the discharge. So the battery is disconnected and connected with this resistor. So this is the simple discharging of a capacitor. So we can write down this capacitive voltage and the voltage across resistance. Total must be 0. Using KVL where there is no source. So Q V equals to Q by C and voltage equals to IR. So I is dq dt. So just rearranging, then you will be get this expression, charge equals to like that, and t equals to 0, charge equals to q. So you will be get this one. This q is replaced by capital Q of t. You can initially you can also find taken this q of t. Just this is a notation. So q equal to c v naught. The initially this is q equal to c v naught. So this is the charge. And what is the current? Current is nothing but dq dt, just simply derivative of this expression with respect to time. You will be get this expression. Clear? Next one. What was the original energy stored in this capacitor? Of equation 2.55, you know the energy stored within this capacitor half CV square. By interpreting equation 7.7, confine that delivered to the resistor equal to the energy lost by the capacitor. So the energy delivered to the resistor is nothing but power into time. So power equals to I square R, and you will put this value of current. This is the expression of current. Will be put this value I square R. This one R is cancel out, and this square that is a 2. Just integrating this, you will be get half CV V naught square. So you can easily find out that this capacitive energy is supplied to this resistor. So this energy from the capacitor supply to this resistor. Next one, determine Q of t and I of t. So now this voltage connected with with this circuit. So this using KVL, Q by C plus IR equals to V naught, and just rearranging them, Q equals to I equals to dq dt. So this separate out and then integrating at t equals to 0, Q equals to 0, at t equals to t, Q equals to Q. Taking this integration and rearranging them, you can easily find out this Q of t equal to C V naught 1 minus J minus T by CR. So this is the charging of the capacitor. This is the charging of a capacitor. So this corresponding current will be dq dt. This is the expression of current flowing within this circuit. Next one. Find the total energy output of this battery. So V0 I, this is the power, I V0. So this is the power. Put this value of current V0 by R. This is the expression. So C V0 square, that is the power output from the battery. Determine heat delivered to the resistor. So the heat delivered to the resistor is simple from PdV, and this is the same calculation where we already obtained. So just put this value half CV naught square. Okay. So this is the heat delivered to this resistor, and the energy of the capacitor half CV naught square. So uh, you can see easily that is the energy supply by this battery is shared by these two elements, that is resistor and the capacitor, and this is the half, this shared by the half. That means total energy supply from this voltage source is shared by this capacitor and the resistor by the half of its total energy. Right? Next one. Sorry. Two metal objects are embedded in weakly conducting material of conductivity sigma. There is two metal and these are connected by this conducting material sigma. So the resistance between them is related to the capacitance like that. You know current I equals to J ds. J is the volume current density. I is the linear current. ds is the area. You know J equals to sigma E. So put this value E dot ds by Gauss theorem, q by epsilon naught. So q equals to cv. So v equals to ir. So I cancel out. You will be get easily r equals to sigma 1 epsilon naught by sigma into c. Clear? Next one. Suppose you connected a battery between 1 and 2 and charge them up a potential difference V0. Connect this within a battery and potential is V0. Then disconnect this battery and will gradually leak up so that this voltage is like that at the time constant. So there is Q equals to CV and V equals to IR. So dq dt equals to minus I, which is like that. Put this value of I here. So dq by q and this I equal to dt by t, integrating you will be get this expression. So the voltage equal to q by c. So the corresponding, put this value of q, you will be get v0 this. So this will be matches where tau is nothing but the time constant, that is the cr. Okay. So r is the obtained in this expression. Put this value sigma naught by epsilon naught by sigma c. This is the value of this constant. Okay. Next one. Suppose the conductivity of the material separating the cylinder in exercise 7.2 is not uniform, especially sigma is related to like that. Find the resistance between the cylinder. So the simple process as we just previously used. This is the area, this is the surface current density, sorry, volume current density. So J is equals to like that, and E is J by sigma. So this will be this value, and sigma is nothing but K by S. Putting this value, you will be get I by 2 pi K L, and potential difference E dot dl will be get this thing, and resistance equals to voltage by current. You will be get this resistance. Simple. Just follow up this process, you can easily find out the resistance between them. Clear? Next one, a battery of EMF epsilon and internal resistance small r hooked up a variable load resistance r. This is variable load resistance r. If you want to deliver maximum power to this load, what resistance would be choose? So this will be the current of this circuit, EMF by total resistance. So the power will be I square R, and this power will be maximum. So the derivative will be 0. So if you take this derivative with respect to R, this will be 0, and from this you can easily find out this R equals to R. That's mean the power will be delivered maximum to this load when this small r is equal to capital R. When these two resistance are equal, then the maximum power delivered to this load from the battery. Go to the next one. A rectangular loop of wire is situated so that one end height is between the parallel plate of capacitor. This is the figure. This is the circuit. Okay, what will be the EMF of the circuit? If the total resistance are, what will be the current flow? Okay, the EMF produced within the loop will be 0 because this here the electric field is constant. Okay, so the you can write down these things as a whole, but this will be possible if the only in the inside the electric field present and the outside electric field will be 0. But at the edge, you know, this there will be a eventually right of kilo of the constitution, that is the left of this loop. That means at this edge point there will be does not satisfy this condition actually. That's why this is not true. Actually the EMF also 0 and the corresponding current will be also 0. I think clear. If there is any doubt, you must comment in the comment box. This is all about me. This is my contact details. You can connect with me with this Telegram channel to get the notification of the uploaded video, or also you can get the PDF of this lecture. You can join with this Telegram channel to obtain the PDF copy of this lecture. Okay, this is my social media or the online platform. You can connect with me from here also. And this is my YouTube channel details. Go to this channel. You will get the different physics related topic discussion, and if you like if you learn something from this session, you can like this, share this video to your friends so that he or she also get benefit from this video. Subscribe this channel if you new in this channel. Those already subscribed, thanks for subscription. Press the bell icon to get the notification of upcoming video. So take care, we'll meet in the next video as soon as possible. Thank you.